Okay. And basically, if you look at the example, example 13.5, what they do is they take this equation and they say, okay, I'm going to divide both sides by m, and I get k q, little q, divided by the mass of the electron divided by r, and that's equal to the velocity squared, the velocity of the electron flying around in orbit. Okay, and so what they do is you can look at the example, I'm not going to do this, but they take that example and they plug in for the hydrogen atom, they plug in the, this would be the plus 1 for, this would be 1.6 times 10 to the minus 19 coulombs for the proton, and this would be 1.6 times 10 to the minus 19 coulombs for the electron. They plug in the mass of the electron. That's the mass of the electron is 9.1 times 10 to the minus 31 kilograms. That's real small. And they plug in the orbital radius, which is quite small, 5.29 times 10 to the minus 11 meters. And they come out with a velocity, and they do that on page 447 and 448. We're not going to do it, but you can actually calculate the velocity of the electron. Now, is this a true velocity of electron? Not really. It's according to what's called the Bohr model of the atom, it is. But we will talk more about this in the numerical lab. Actually, we're going to go much more into detail into what the Bohr model of the electron is. So, in fact, we'll solve this. Actually, we're going to duplicate some of the quantization steps, the quantizing steps that Bohr himself went through, and we're going to come up with a quantized model of the atom. Okay, well, in next videos we're going to do all the problems and then go over the labs. So long.